Welcome back, guys, to another episode of Physics Presentations. And today I am Maxwell Sue, and I will be showing you how physics is just like eating sawdust. Now, a question you all may be wondering, how exactly is eating sawdust related to physics? Well, I think that the experience of eating sawdust is related to physics because really it's about jumping into the experience. And I think that really it's more about gaining that uniqueness and that rather than the flavor itself. Just like how AP Physics, it's not really, AP Physics is difficult. It's not easy to understand, but it's about that experience, a unique experience that you really can't find anywhere else. And I think that that really is what encapsulates AP Physics to me. I think that's what really embodies the core of the class. Now, what is physics not? Let me tell you what it is not. It is not about equations. Now, this point has been referenced a couple times now, but I will say it again because it really, it's not about the numbers. The numbers themselves, they're just ink on a paper. They don't mean anything. Physics class, I think, really teaches you that to give meaning to these equations, you really have to understand and experience these things in real life. Like, physics is physical. You know, you have to understand that physically these things have an effect, and you are the one who has to personally give meaning to these numbers, because otherwise these equations are just that, numbers. They don't mean anything unless you give them that meaning.
And you said you had a reaction when I gave you the equation sheet.
Right. At first, when I got the equation sheet, I was like, "Ah, man, I'm set. Like this is it. I don't have to do anything." But after a while, I realized, like, yeah, you did. That thing was literally every equation you would need from now to the end of time, but or at least until the end of AP Physics. But I realized that very quickly that the equations just didn't encapsulate the experience. That didn't sum up anything about the class at all. You could really just see that was literally everything you needed for the class. Yet it didn't mean anything. It didn't actually teach me anything, and it didn't encapsulate the experience of the class at all. And that really segues into my next point, that physics is not about grades. Mr. Turgeon brought up a great point that he asked me, like, when you take, couldn't I just take a bunch of tests and learn everything about AP Physics? That encapsulates technically everything we needed to know, right? But I think that really that doesn't. Unlike some classes where you could maybe take those tests and get most of the experience. No, I think that physics is really about the learning, and I think that things like the labs, all of that really was actually where most of the experience was contained. Unique from many other classes where those assessments really didn't, to me, encapsulate much of the spirit of the class, I think. And that was something that was really unique to this class, I think, and particularly really gave it a feeling to me that I felt was something that I took away from this class in particular, something that I didn't really feel in many other classes. And physics, people say physics is so complicated. It's this top level class that you gotta. It's rocket science, but it really isn't, unless you did the bottle rocket experiment, in which case it was rocket science. But other than that, physics is really not. It's really physical. If you can see a ball rolling, and if you push that ball harder, the ball might go faster. It might go slower. And just documenting that experience, it's not something that you actually need a tremendous amount of brain power and intelligence for. It's not something that is this like obscure, really narrow field that only a few select nerds can kind of get into. No, it's actually really the experience. If you're committed to that learning and if you're invested in that subject, anybody can gain a lot from this class. And I think that was something that really struck me, that it's even in such a high-powered class with so many intelligent people, really, that it wasn't really all of that difficult to understand somehow. Like some of our experiments really came down to literally just put this thing on the scale, and when the thing is heavier, the scale reads more. But what does that mean? What does that really get into? And I think it's really not as difficult as people really think it is. And that kind of goes into my next point, that physics is really a class that taught me about failure. Like a lot of classes, oh, every class echoes, you don't need to get these things right. You don't need to, it's all about the learning. But at the end of the day, you needed, on those assessments, you needed to get the answer correct. And now, AP Physics, to its credit, isn't any different. Yes, you need to get the answers correct on the examination in order to get a good, to pass. But again, like I mentioned earlier, I don't think that's the spirit of the class. The spirit of the class is really rooted in the discussion, the experimentation, that period of time between tests rather than the tests themselves that encapsulated the class. And it was during those periods where we were encouraged to really get into failure that all of these people were struggling, and things failed, things went wrong. We had labs where you just wrote down that you didn't prove anything. Your lab did not prove what you objectively sought out to complete. However, it was the curriculum of the class and the attitude of the people within it that really gave it that experience of not only accepting failure, but almost encouraging it as something that is not any less than success. It is not secondary to success, where failure is sort of the secondary objective that, if you can't quite reach success, you could take something from failure. No. The AP Physics really taught me that these two things were just as equally valuable and important, and in a way that was really unique, because those examinations were not the spirit of the class. The spirit of the class was within those labs and experiments where failure was just as worthy of appreciation.
And what about failure on the homework assignments and problems?
Yeah, and on homework assignments and problems, yes, you needed to, you should obviously be encouraged to get the answers right, but at the end of the day, as long as you showed that effort and that learning, if you went through, like, for example, the practice test for a big scary test, you didn't need to get answers right. You could get a 20% on that homework assignment, but as long as you could go back and understand those mistakes, it's just as valuable, and that's worth just as much in the grade book. And I think, especially with Mr. Turgeon, you giving us the opportunity to show physically with those grades, like it's just as valuable, it's just as worthwhile, and that you didn't have to feel pressure to get the right answer in order to feel just as that wrong answer is just as valuable. It's not subpar in any way to success or getting the correct answer necessarily. And rather similar to that, imperfection. Even how in a lot of classes it's very, very binary, that you either succeed, you get the right answer, or you do not. It's either you went through, you used this equation, you got this is the answer. This circle has a circumference of this, and that's either correct or it's wrong. But in physics, it really taught me that, especially with all this experimental error, things are imperfect. That yes, we hold all these physics equations and laws all over the place, things can't lose energy, but at the end of the day, real life is complicated, it's messy, and you're never going to get exactly perfect. And if you get too perfect, that's actually a cause for quite some concern, because the world doesn't work that way. And I think, especially expanding that and accepting that, your answer is not gonna be exactly correct. And all you can do is make your best judgment as to why, how, or whether that imperfection is some cause of concern. Because you're never going to get 100% perfect, but you can get pretty close. And I think understanding why you can never be perfect can sometimes be an experience that is very unique to the class, because there are some other classes where, especially like English or chemistry, for example, where yes, error and things like that are discussed, but I think it's only in physics that really, really specifically encouraged me to identify the source of this error and why it can't be corrected, where these things, they're almost just as it's almost just as much a law that things will go wrong. And I think that that was really something that I felt was a big major theme of physics from beginning to end. And now hypothesis. Now, that physics labs were really interesting to me because unlike a lot of other labs, you were really not given too much direction. You had an idea of where you were going, but at the end of the day, you could really formulate your own questions. You didn't have to you didn't have to follow necessarily a set of instructions. Even procedurally, like, yes, you went through the procedure, even if it was the exact same thing as everybody else. Everybody was able to create their own unique ideas, their own unique presentations, that very much in the same way this presentation very much encapsulates that feeling. Like, yes, we all went through the same class and we did the same things, yet we were able to all come up with our own unique experiences and ideas. And I think that that crossing and trading our ideas really not only was it help make this class stand out among other classes, but made it an experience individual to me personally, that obviously that my experience is going to be vastly different than everybody else's, and that curiosity and that wandering was really, really integral to the learning and the experience of this class in a very uniquely, I believe. And obviously, discussion, we have these great ideas, we have all this learning experience, but there's a reason that things have to be learned in groups. There's a reason that societies of research are done. Research is done in groups. People trade ideas. People look once you get into research, people look over each other's papers. They submit it in order to get it verified by other people, because discussion is how you really achieve true understanding of subjects, in my opinion. And I think AP Physics really encapsulated that idea, because you had to sort of discuss, because a lot of these ideas are difficult to learn. They're not necessarily very clear and very easy to sort of picture unless you were just given the answer beforehand. But even then, everybody understands a little bit here and there of this idea. But it's when you put those pieces together, now you can form the complete puzzle. Everybody has a little piece, but it's only by putting those together that you can really form a more complete picture of what you're supposed to be learning. And like we said before, the hypothesis, everybody has their own unique hypotheses, but it's by putting those together, you can exponentially increase the amount of learning that you can gain from one experiment, because everybody takes something a little bit different out of that, and it's by combining those ideas that you can really gain a lot more than you could ever on your own. And lastly, just back to the point here, curiosity. At the end of the day, nothing will ever get done unless you agree to just try. And everything from basic human progress was always rooted within the idea of curiosity. We do all these things. The first people to grow crops or discover medicine or invent electricity, they didn't do that for like a specific reason. They didn't know that those things could be done. They did it purely just because they were curious. All they had was this raging curiosity within them, and I think that even now that was something that really was integral to the idea of physics class. And I think that that's something that really, really struck me, that it was really about that curiosity. And at the end of the day, it was that curiosity that drove everything we did, because you don't really take AP Physics if you're not curious. You don't really get into that idea, and I think that that really encapsulates the class. Now, here are some examples of some problem solving that we had to do, right? And really to the point here, we had this idea that for the obviously none of us had ever seen this kind of contraption before, and all we had was this idea, and we thought, oh, you have a torque that's driving these masses, you can calculate that inertia. It seemed like a great idea to us, and we put that in. We were so excited, and we put that in to get 62% error, and we were like, man, this is wonderful. This is great because it really, the problem solving, it's not necessarily to get the correct answer. 62% error was great to us because it showed us that it's not that easy. If it were so easy, it wouldn't be rewarding. You know, going through and understanding why these things happen is far more a part of the experience than getting the right answer, I think. And experiencing that failure and that imperfection is really what drives that curiosity. You're curious as not just to get the correct answer, but you're curious as to why things fail. And I think that's all that getting the correct answer is half, but why things fail is just as important to the class. It's just as valuable. Now, my philosophy here, again, sometimes you just have to make that first step, you know. Whether it's even just agreeing to take the class, whether it's getting started on the lab, you just have to take a step forward. And I think that is something that really struck me. Like on some of the labs, I would get up to 10, 11 o'clock and I would be like, man, I still don't have anything. But as soon as you agree to give it a shot, give it any idea, just throw something in, you'll realize very quickly that the pieces start falling into place. You know, when you start taking the class, you think, man, this is crazy. Like looking at that equation sheet, I have no idea what any of this is. But bit by bit, you begin to see that things will click and you'll begin to learn. But you just have to be willing, just like eating that sawdust. You just have to be willing to give it a shot to really gain that experience. And problems were more like puzzles and not assignments. That it was about the process. You don't necessarily complete a puzzle. The enjoyment of a puzzle is not necessarily derived from its completed form. Otherwise, that's the same as a painting. You know, it's not really any different. It's the puzzle is about the process of derivation in order to arrive at that completion. It's about that process, and I think that really encapsulated physics problems in general as well. It was really about the thinking, the process. It wasn't about right or wrong at the very end. And you know, to restate a point here, perfection is a lie. Anybody who tells you that you can get the right answer, that's a lie. There's only mostly right answers or mostly wrong answers. It's all shades of gray, and that's something that you really have to have that mindset in this class. And I think that that's really part of my personal philosophy. It's all just a spectrum. It's not right or wrong. It's not good or bad. And lastly, I think you really have to find your own philosophy here. That I think something that made AP Physics so unique to me, and I think should be part of my philosophy, is that everybody created their own version of physics. Everybody has their own experience, and that it's never going to be the same for everybody. And that uniqueness is something that you must derive on your own. Nobody can tell you what you're meant to gain or lose. Like my entire presentation was based on this one throwaway moment like 4 months ago that it was just by chance. Maybe if he had given that to somebody else that day, I wouldn't have gotten this opportunity. And you just got to roll with it. You just have to find your own path. And I think that that's something that you can take solace in, that you don't have to follow the beaten trail. You can, no matter what happens in this class, you can gain something out of that. And I think that you should find relief in that, because at the end of the day, you take whatever you want, or you don't take whatever you want, and that's all great. So, thank you.